Today, we're going to go over the challenges that COVID has presented to the contractor world, plus advanced air systems, what we're doing to make sure we keep your client site safe, as well as our employees. After that, Paul's going to go into HVAC 101, but then dive into why everyone's here, I believe. How can we filter out COVID in our indoor air quality?
Well, thank you, Kevin, and welcome everybody to this, our second Zoom. Yesterday we had one on Roofing 101, and today is HVAC, air conditioning, and air quality control. Just a little bit of history about myself and our company. I grew up on Long Island, New York, and I worked for a roofing company through high school and college. I offered a position to open a branch in Atlanta for my boss, and he moved me down to South Florida in 1982. So I worked for him for over 10 years, and then I borrowed $15,000 from my dad, bought a pickup truck, and we started Advanced Roofing. Advanced Roofing has grown over the years due to its core values, its culture, commitment to quality, focus on our customers, and focus on our employees. We've been very successful at that, and we continue to thrive. And I just want to thank some of my longtime customers. I got Public Supermarkets over 30 years, FP&L over 30 years, and many, many other good clients. I don't want to start naming them, but we have over 60 people today to learn from Paul Murphy a lot about HVAC. So with that, you see up on your screen, there's actually, Kev, go back one. I just wanted to point out a couple things. On the bottom is my twin boys, Kevin and Mike, and my grandson, Mac. So we have 3 generations in that photo, and I'm very proud that my boys are doing so well, and they're my partners now, along with Clint Sockman. To the left is one of our community things, Tutor Me. We actually have employees that get on the phone and have first graders read to us, and it shows that the reading goes from a 25 percentile to 75% just in 1 year by this program. And other pictures, company is a large family company. We call it over 560 employees right now. So next slide, Kev. As I started, these are unprecedented times. It's just, we don't know exactly what's going to be on the other end of it, but we do know it's not going to be the same as it was before. Similar to 911 and TSA and airports, and the way we do everything is going to be different. When the governor came out with his order, we decided that we were an essential business, similar to other contractors. What did we do? We immediately got washing stations, masks, and did all the precautions way ahead of a lot of other people. We were even complimented by Pratt Whitney, one of our longtime clients as well, Broward Schools, on how far advanced we were immediately when we got our people back to work out in the field, because we want to keep everybody safe, not only our employees, but our clients as well. One of the things we did is we bought these masks. These are actually Guy Harvey masks that we bought for our field guys. Little story with Guy Harvey. I've been working with Guy with his research on Mako sharks. We put satellite tags in Mako sharks and they track them. We actually help stop the killing of Mako sharks on long line fishing boats. They have to release them live. And we have a 5-year project going on in Panama as well. We do a lot with the community. This weekend was MS Bike Ride for our 17th year. The Advanced Roofing Tar Peddlers was going to put its team in there, and we actually are the highest fundraiser this year at $52,000. So we're going to miss that. We're doing a virtual one live Saturday. We're going to just do it through Facebook. But, we try to adapt in these times, and we are. And by doing this is new to us. We've been practicing, but I think it's going to be very valuable to be in contact with our clients as well as your businesses as well. Advanced Air Systems started in 1994. If you look to the left, that's one of our first trucks at Scott Milan. He was a neighbor of mine, and I purchased his building, and we branded it just as Advanced Roofing, and then Advanced Air Systems came about over 10 years ago when we wanted to expand from doing our own work, because there's so much HVAC with roofing. That's why we got into the business, and then Advanced Roofing as well since 1983. So with that, I want to introduce you to Paul Murphy. Paul's been with us for almost 4 years now. His father, son, he came over from his dad, and really pleased to have him, what he's doing, and he's got a great presentation for you. So thank you for coming. I think it'd be worth your day and worth your time.
Hello, everyone. As Rob said, been working with Advanced Air Systems for over 3 years now. Over 18 years of HVAC experience. Everything from water-cooled systems, you got your chillers, your cooling towers. I have certified in heat load calculations, variable frequency drives, and variable refrigerant volume systems. Also certified in modine coating, so if you need a modine coating, we can take care of that for you. For fun, I like to do drifting, if you ever heard of that. And the other polar opposite that I like to do is grow fruit trees. I have over maybe about 150 different fruit trees at my house right now. So a little fun fact. So we can move to the overview now. And today I'm just gonna go over just a high level of HVAC systems. Don't wanna get too into the weeds with that, but we'll go over some terminology and the basics of HVAC. Then we'll go into health hazards of our indoor environments and COVID-19, which I'm sure everybody's here for. And then solutions to those hazards. So we'll offer some solutions that can help your indoor environments. So now it's poll time. We're going to go ahead and send a poll to you guys. What does BTU mean? Does anybody know what that means? Go ahead and submit. You should have a poll appear on your screen, and just go ahead and submit your answer. Give that a second.
Yeah, Paul, give it about 10 more seconds, and then I'll share the results.
Great.
And if you're having trouble finding the poll, it should be at the bottom where the chat board is, and there's a little icon that says polling as well. It might not pop up on some screens or telephones. So sharing the results here, it looks like the overall winner is British Thermal Units. So it seems like we've got some pretty educated dialers in. So appreciate everyone's feedback there. Paul?
Yep, great to know. So here we go. British Thermal Units, yes, so that's BTU, it's British Thermal Units. The measurement of the cooling output and heating output. Then we have ton, everybody's heard of ton. So at 1 ton is equivalent to 12,000 BTUs per hour. EER, energy efficiency ratio, is calculated using constant inside and outside temperatures. And then you have your SEER, which is your seasonal energy efficiency ratio. That's the one that's, it calculates for a year's worth of weather. CFM is cubic feet per minute. That's a measurement of airflow. RTU, we hear this a lot. Rooftop unit. It's usually a self-contained package unit on your roof deck attached to your roof curb. Some people will call a condenser a RTU. It's fine. We'll understand what you mean. Then we have AHU. That's an air handling unit. It's a device used to regulate and circulate air as part of the heating, ventilating, and air conditioning system, HVAC. CU, that's your condensing unit. Main function of that is the heat exchanger and compresses the refrigerant from a gas into a liquid. Next we have is chiller. It's a mechanical device used to facilitate heat transfer between water and refrigerant in a closed loop system. And then cooling tower, that's a specialized heat exchanger in which the air and water come in direct contact with each other. And that direct contact causes evaporation, and that evaporation cools the water down. So here's, so we're going to talk about a split system just to get a high level view. So this is a condenser. In a package unit, you have the condenser and the air handler. So this is just a condenser for the first part. The compressor is the heart of the system. It compresses that refrigerant and pumps it into the condenser coil as a high pressure refrigerant gas. The condenser fan motor, that's a vital component. It pulls air across that condenser coil to facilitate the heat transfer that is needed to take that high pressure refrigerant gas that the compressor pumps out and turn it into a liquid. So then the condenser coil is where the actual magic happens. That's where it removes the heat from that high pressure gas and cooling it and causing it to turn into a high pressure liquid. That all gets pumped out of the condenser and pushed over to the air handler. So we move to the air handler here. And then when it gets to the air handler, the first place it arrives is the expansion valve. That's what changes its state from a liquid refrigerant, which is high pressure, to a low pressure gas. that cause that state change as it moves throughout the evaporator coil causes the cooling effect. So it's removing heat from the air as the air flows by it. So as the blower wheel pulls air across the coil, to facilitate that heat transfer between the evaporating refrigerant gas and the aluminum fins, and then it blows it out into finally sending it through the ductwork and providing your building with nice, cool, dry air. So I'm going to the next slide. Okay, so this is it all together. This is the refrigerant cycle. So it starts at the compressor. The compressor pumps the gas into a high pressure gas, just like we were saying before. It flows on to the condenser coil. That's where it gets cooled. The heat is released and it's turned into a liquid. That liquid flows down to the expansion valve. That expansion valve expands that liquid, the high pressure liquid, into a low pressure gas again, flowing through to the evaporator coil. And then as it expands, it soaks up all that heat from inside and then blows it right back to the condenser. So basically what an HVAC system is just a heat transfer system. So we're just taking heat from inside and putting it outside. Okay, we're gonna do another poll. What is IAQ? Does anybody know what that means? Give some time for the poll results.
Again, while we're polling, there is the Zoom chat. So if there's any questions, if you want to type them in, I'll try to address them throughout the presentation, or I'll hold the Q&A session for the end as well.
Great.
Yeah, so the correct answer is indoor air quality. So great job.
Okay, move to the next slide. So what is IAQ? It's indoor air quality. Before COVID, we spent 90% of our lives indoors. Now it seems like 100% of our lives, which was exposing us to all the indoor air pollution that builds up in our spaces. But none of that seemed to really matter to most of us until now. Today, if someone sniffles 10 feet away from us, we give them dirty looks. We don't want anybody next to us. Some of those common indoor pollutants are mold spores, viruses, bacteria, particulate matter. So even particulate matter can be dangerous to us if it's the wrong size. So we don't want small particulate. We want big particulate that will fall on the floor. It'll be caught in filters and not brought into our lungs or into our blood system. So the next one is volatile organic compounds. Everybody's heard about that, VOCs. You got carbon monoxide. We know about that one. That's a dangerous one. Carbon dioxide. We breathe that out every day. Global warming. Ozone. It's great for our atmosphere, but not good for our lungs. Those are just a few. We can go dive more into that in the next slide. Where does it all come from? So we can talk about each one. So we know the carbon dioxide and tobacco smoke. Viruses and body odors come from us, right? But the dust, the fiberglass, the asbestos, the gases that are outputted is from the materials we use, whether it be Chinese drywall or we have asbestos on our pipes or insulation. So we got to be careful of those. Dust mites, those are carpets, fabrics, foam cushions. That's where they like to live. They eat dead skin cells. Then the gases, the vapors, the odors, the formaldehydes, the VOCs, those are all coming from your furniture, your carpets, your paints, your workplace cleaners, your solvents, your pesticides, and your disinfectants, glues. Microbial contaminants, so the fungi, molds, bacteria, those are in damp areas, stagnant water, your condensate pans. So that's the reason why we want to do the maintenance, is to get all that out of your condensation pans. You're going to get it out of your drain lines and make sure it goes on. Next is ozone. Probably a lot of people don't know that ozone is created by photocopiers as well. Photocopiers, electric motors, electric static air cleaners. That's why we don't recommend those, because they create ozone. Move to the next slide. Poll time again. How much droplets of mucus and fluid can a single sneeze produce? What do we think? What do you think, Kevin?
Probably too much for my liking.
Give it some time. I assume we resolved the echo issue. So if we're still having an echo, just let us know. Okay, there we go. Okay, so actually it's about 40,000 droplets. So we had a good, nobody thought it was 250, so we had a good idea of how many it was. So the worst threat to our indoor air quality is us. Our cough sneezes represent one of the worst threats to our indoor air quality and our health. A single sneeze could travel over 70 miles an hour, 75 miles an hour. A sneeze can produce 40,000 droplets of mucus and fluid. Sneeze can spray up to a radius of 6.5 feet, probably a little bit more, as you can see in this video that we're going to show right now.
Don't you dare sneeze on me. Do you know how far your germs can travel?
Normally you hold about half a liter of fluid in your lungs. So when you sneeze, you're able to spray as much as a water bottle's worth of mucus into the air around you. It shoots out of your mouth in the form of moist, germ-infested clouds, traveling up to 35 meters per second. That's fast enough to give you a speeding ticket on the highway. Once that cloud hits the air, it expands, breaking up into snotty strings, then a series of different sized droplets, all trapped in a turbulent gas cloud. One brave group at MIT discovered that the biggest droplets can travel up to 2 meters, about the distance between your desk and 2 desks away. But most other droplets? Those travel much farther, up to 8 meters. That's about 5 desks away. Not only that, the germ-infested gas cloud is less dense than the air around it, so it rises upwards, right to where ventilation systems and other people's unsuspecting noses and mouths await. Even though these are relatively smaller droplets, they're probably still teeming with harmful pathogens like the flu virus. Even worse, depending on the ventilation, they can spread through a room in just a few seconds and remain suspended for up to 10 minutes. Now, if you happen to notice someone around you sneeze or cough, you can hold your breath as you move out of range. But during the flu season, that might not even be enough, because there are danger zones everywhere, especially on surfaces like desks, doorknobs, and steel handrails. It turns out the flu virus has been found to survive for 24 hours on a steel surface. And if you touch that surface and don't wash your hands before eating, you may have just gotten infected. So let's say you go into work sick with the flu one day, and you start to sneeze. Now, according to one study, you'll probably only infect 1 to 2 other people. You're clearly showing symptoms of the flu. However, it's going to take a few days for symptoms to show up in other people you've infected. So those poor souls unknowingly also come into work sick over the next few days. And they will potentially infect 1 to 2 more people. In an office of 100 desks, this could mean 10 or 15 sick people by the end of 2 weeks. That's over 10% of the office. And all of it started with just one sick person. You. All thanks to the germ-laden cloud you so generously shared. So the next time you're not feeling great and you're sneezing up a storm, just think about your poor coworkers and take a sick day for yourself and for them.
Okay, next we have finding the healthy zone. The three-headed dragon of indoor air quality is humidity control. So as you can see from this table over on your right-hand side, it shows where these viruses, bacteria, what the range they like to live in. So the healthy zone is where we want to stay in. So for viruses, it's probably in the 50, 60 range, which is good for us because in South Florida, we usually stay in about that range because we're too humid to even get any lower than that. So you don't have to worry about getting a humidifier usually. Just make sure that your AC is running fine and bringing that humidity down at least to below 60. So those humidity levels, high humidity can cause respiratory issues, encourage dust mite life, allow virus and bacteria to increase, allow VOCs to become airborne, increase the chemical reactions and microbiological growth to take place. That low humidity levels cause respiratory issues as well, irritate the mucous membranes of your lungs, allow viruses and bacteria to increase, and for production of ozone. The healthy zone falls for humidity falls between 35 to 60%. But like I said before, in Florida, we're usually 50 to 60 is where we can do, unless you have a dehumidification system. Next slide. Here's a healthy zone for all the different sections here. We got temperature. So anywhere where you're comfortable between 68 and 75 is where it's healthy. And your humidity, again, that's 35 to 60%. You want a slight pressure in your building. You don't want too much, and you don't want any negative pressure. So you want to make sure you get the outside air in there, and that's where ventilation comes in. Making sure that your rooms are properly ventilated, that you're getting ventilation to your air handler, so that way you're getting that positive pressure. What we know about COVID-19. Now, this is always changing, but we have a couple of facts here as of now. In an aerosol, a sneeze, it will last around an hour. On a copper surface, it will last up to 4 hours. Cardboard, so like your Amazon boxes, 24 hours. Stainless steel surface, 48 hours. Plastic, 72 hours. So your grocery bags or any plastics, it lasts up to there. So that's why we want to make sure we want to sanitize those. This virus is so small, it'll slip right through your filters because it's 90 nanometers. There's no filter that filters down to 90 nanometers. So the biggest that a filter, like a HEPA filter, can catch is 900 nanometers. So it'll slip right through there unless it's attached to a particle or water droplet. It can be killed if exposed to 135 degrees for more than 15 minutes. So that's what we know about coronavirus. Next, we have who or what is MERV? Who is this guy? What is it? Do we know? Go ahead, everybody should see the poll and make their choices.
Looks like we got a close one here, Paul.
Oh, really?
Yeah.
Okay, cool.
It's
Sounds
going
good.
down to the end here. I'm gonna shut it off now.
Let's see what we got. Okay, split. Wow, cool. Okay, what we're gonna learn then. So MERV, it's a weird acronym. So minimum inefficiency reporting value. It doesn't really mean anything to you, even when you explain it, right? So I'm gonna try to break it down for you so that it makes sense. So here we have a little table on the right-hand side that'll explain it and better. So we have MERV 6, that's your bare bones. You're only going to get lint and household dust. The MERV 8 only gives you additional dust mites and mold spores. MERV 11 will catch pet dander, smoke, smog, and a cough or sneeze droplets. So that catches droplets. Now your MERV 13, those will add bacteria. So it'll catch most bacteria, and it'll catch virus carriers. So it won't catch the virus, but it'll catch, something that the virus would be riding on, so as a water droplet or a particle big enough for it to catch, which a MERV 13 catches, like I said, somewhere around 900 nanometers, or I think it's 0.03 microns. Okay, we'll move on to the next slide. So we go into HEPA filters. These are high efficiency particulate air filters. They usually utilize a powerful blower because they're very restrictive. The pros about them is they're very efficient in filtering air that passes through the filter. Back again, here we go. It says 0.03 microns. So this is the smallest that you can filter out. So the viruses do go right through this. That's the cons to it. So, but it still requires filter changes, and they're very expensive, and filters are always breeding grounds for mold and fungus. Same thing with carbon filters. Great thing about carbon filters, they're impregnated with carbon. So what it means is carbon usually absorbs, or it does absorb odors, absorbs gases, and it's also a filter as well, so it filters out the particulate. Again, this is an expensive throwaway filter. If you're worried about odors and gases, you go ahead and use this. You can use carbon filters in your standard HVAC system. That's the nice thing about it. You cannot use a HEPA filter in your standard HVAC system. It has to be a separate unit. Next slide. So we have the standard foam fiber filters. These are comprised of a mesh of foam, fiberglass, wire, plastic, or cloth. These usually only stop medium to large particles. So these are your MERV 8s, MERV 6s. They're low cost, low air resistance, and most units have these. But again, it's a breeding ground for bacteria, and it only filters large particles. Next, we have ion generators, negative ion generators. These have been used for years in the medical industry as well for neutralizing the effects of excess positive ions. These negative ions attach themselves to different particulate and attract other particulate, making the particles bigger than they were before, causing them to drift down to the floor or get caught up in your standard foam filters. So it makes so the ion generators make your standard foam filters work a lot more efficiently. So the only cons about them is it drops a lot of particulate on the ground, so you're going to get more dust around so you got to make sure you're cleaning that up. And the ions don't flow effectively throughout the ductwork. Next slide. We have UV light. Everybody knows about UV light, I think. It's been used as a sanitizer in the medical profession for years, still is. It's very good at sanitizing. It just has to have the proper exposure times. Okay, so the pros about it can destroy bacteria, fungus, molds, gases, viruses, and it does not reduce the airflow. The cons about it has no effect on particulate. So that particulate matter I was talking about before, we want to bind those particles together to make them bigger. It doesn't do that. And it needs direct contact and a proper exposure time in order to be effective. Next, we have the RGF Guardian Reme Halo. This is what I suggest, and this is what I do put in a lot of facilities, even our own facility. And we're going to watch a little small video on it, and we'll go through explaining.
The high occupancy of commercial buildings makes them one of the most polluted indoor air environments. The Guardian Air Reme Halo by RGF can reduce these contaminants at the source. Installing easily into any forced air system, the Reme Halo is designed to recreate the natural way the environment removes impurities in outside air. It does this by sending out ionized hydroperoxides into the space where you work and breathe, attacking microbes like bacteria, viruses, and mold spores, destroying impurities like VOCs, chemicals, and odors in every cubic foot of air in the building at the same time. The Reme Halo even improves your existing filtration by causing the allergens to stick together, increasing filtration rates and energy efficiency without sacrificing airflow. Medical facilities using the Guardian Air have shown a decrease in MRSA cases, and long-term care facilities have saved tens of thousands of dollars by eliminating chemical odor cover-ups and increasing worker productivity. Public schools have shown a documented 15% decrease in absentee rates. The Guardian Air Reme Halo is the only product laboratory tested and proven to reduce the germs in a sneeze by 98% before they travel 3 feet. To find out more, visit rgfairpurification.com or talk to your local air conditioning and heating contractor to start breathing cleaner, fresher indoor air.
Yep. So the great thing about the Reme Halo is that we can install it in a very wide variety of HVAC systems. It doesn't require much room. It installs into ductwork. So it's not even really on the unit. It flows throughout all the spaces. And like you said before, so before the sneeze can travel 3 feet, it's already in the air. So it's already reduced the germs by 99%. So, and the zinc ions that it releases kill all the viruses on the surfaces. So it's just really a great tool that we use in order to control these indoor pollutants. Next, we have.
Hey, Paul, we have
Yeah.
a question
Okay.
from Nick Leamer. I just I unmuted you, Nick, if you have a question or if you want to type it out.
I see a question in the chat.
Yeah, I unmuted Nick. It looks like we're getting some questions from Marshall and Sergio. Is RGF expensive? What is the cost?
Okay, so we can all say what is the cost of our health, right? But all these things have the same. It all has to come down to cost, right? So these last 2 years, and if you compare it to, say, your carbon filters or your MERV filters, each MERV filter is going to cost somewhere between $20 to $30 per MERV filter. Your package unit may have 6 of those, 8 of those, and you have to change those MERV 13s probably every 3 months to 6 months. So once you add it up, you get close to what the cost for a Reme Halo. And the Reme Halo is going to last you up to 2 years before you have to change out the element on it. And it's going to increase the filtration of your standard throwaway filters, and it's going to do a lot more for you than a lot of the other solutions have. Now, granted, all those solutions do work and they do provide a benefit. This one I just have shown is what I recommend because it's so versatile. I can fit it in so many different types of units, and I don't require any modification to the existing HVAC system to get it up and going. And it just improves the air quality so much. And in whatever filters you're using, it just increases them, their efficiency, because it's going to bind all those particulates together, and it's going to destroy the bacteria that's flowing around. And if you're worried about your duct system being infected, it's going to be in your duct system. So where UV light only has to be exposed to those viruses in order to kill them, this is going to be exposed to it. It's going to be everywhere. It seems like we have a lot of chat going on here.
Yeah. Hey, Paul. I'll repeat some of the questions. So I know you talked a little bit about maintenance, but how much maintenance would you say on average annually would be done to the unit?
For this, probably once every 6 months, you want to check it out, make sure it doesn't have any dust collecting on it. It doesn't really have too many maintenance items on it. It just has a metal element that has to be replaced, and that's 2 years long. The ion generators that it uses are self-cleaning, so you don't have to worry about that. Okay,
excellent. And so if you could repeat what the cost would be for the Halo unit for a
traditional. So the cost for what we sell them for, you're going to see it all over the range, but what we sell them for is around $800 to $900. There are bigger units that are used for large commercial units. So like your 60, 80 tons, those are more expensive, but these cover up to at least 20 tons. And that's in the $800, $900 range installed.
Okay. Thank you, Paul. One other question. There's been some other reports about COVID-19 and the microns being 0.125. Why do you think there's a difference from what your presentation had?
What I found in my research was it was 60 to 90 nanometers, not microns. So yeah, if you feel free to send me that link, I would love to see it.
Okay,
that's great.
We could, after this, Paul, we could follow up with the attendee and send him your research.
Yeah, definitely.
Okay, awesome. Thank you. I think we got all the questions answered. If not, please ping back on the chat and we'll get to them. We have a few more slides here around duct cleaning and how that relates to COVID-19 as well.
Okay, so cleaning your ducts, your duct system. Can my duct system be cleaned? The EPA has reported that duct cleaning has not proven to produce cleaner indoor air. Now, they have consistently stood behind this report, and it applies to all duct systems. In my opinion, it stands to reason that cleaning metal ducts or metal line ducts would be effective, at least at removing the heavy debris, right? If you have heavy debris in your ductwork, usually that comes from damage to your ductwork or previous repairs or construction where you have that, or if you had some kind of animal living in your ductwork. There are many before and after representations of what duct cleaning can do for metal duct work. The issue remains for me that the duct cleaning can often dislodge matter that can be reintroduced into airstream. So unless the ducts are left completely clean, the duct cleaning I don't think has been successful in reducing the indoor air contaminants. and you may have cleaned the duct, but have you really reduced the indoor contaminants? The reason I say that is because below are some of the duct systems we have. Probably on the left is what you have in your house. The middle is probably also what you have in your house. But these are very fragile systems. And then the right is commercial, more commercial. I've seen commercial have flex duct and fiberboard. But on the right is your internally lined metal ductwork. And it's very fragile, especially when it's old. So that brush can do some damage to it. And is stirring up those contaminants, is it making it for a healthier environment or not? That's up for you to choose. So next slide, we talk a little bit about the tools. Go back, there we go. Okay, so if your HVAC contractor inspects your ductwork and recommends cleaning, make sure your duct cleaning contractor is NADCA certified. I wouldn't do any work with any duct cleaning companies or contractors that are not NADCA certified. I'd also suggest that you probably keep those two separated. You're going to click this video. I'm going to talk through it. So this is one of the duct cleaning tools. It's not all of them. So you can see it's got a rotating head. And they usually hook up a vacuum to this. So it disturbs the debris, it gets it airborne, and then the vacuum sucks it out. A lot of NADCA certified companies will use a HEPA filtration system to make sure that this air isn't reintroduced into your space. So that was it, cleaning metal ductwork. You can see how abrasive that was. And if you have fragile ductwork like we do mostly in Florida, it can be damaging. So next slide is about maintenance. So the benefits of maintenance, it saves more money over the life of the equipment, improves the indoor air quality, keeps the equipment running efficiently. Properly maintained systems are proven to use 15 to 20% less energy. Poorly maintained systems can increase energy usage up to 60%. It will extend the life of the HVAC system. It'll reduce costly service calls, reduce the risk of water damage. I mean, water damage is huge. And especially with these units in your ceilings or in spaces where we have drywall, the damage could be quite a bit just from a clogged drain line. So you can see on the right there, that's a clogged drain line that we cut open, and that's what you see inside. That's the stuff that we got to clean out and we got to blow out. We got to take care of. If we don't do our maintenance regularly, that's what happens, and that's what builds up. So who should perform this maintenance? Maintenance should be performed by qualified personnel on a routine basis. Technicians who are familiar with the property and equipment spend less time troubleshooting and diagnosing any issues. So it's good to have somebody that knows your building, knows your equipment. And if you don't have a maintenance contract, at least have pre-qualified vendors so that way you're ready to go. So next slide is, I think that's it, right? So we're here to help. So if you have any questions, send us your questions. That's my contact information. Please feel free to call me whenever you need, and I'll do whatever I can to help you. Thank you guys for attending this webinar.